So if we have quickly, if we have a quick look at which tissues can use or can utilize pentose phosphate pathway or can use the pentose phosphate pathway for the utilization of glucose. These tissues include, okay, include liver, adipose tissue, adrenal cortex, testes, lactating mammary gland, and erythrocytes. So these tissues contain high levels of pentose phosphate pathway enzymes. Let's shift to the mechanism or the pathway itself of the pentose phosphate pathway. Generally, the reactions of pentose phosphate pathway will occur exclusively in the cytosol. So it's anaerobic reaction, right? The pentose phosphate pathway actually has oxidative pathway, oxidative part and non-oxidative part. The oxidative step will occur at the beginning of the pathway, which utilizing glucose 6-phosphate as a substrate and will generate an ADPH. Okay, so the oxidative step or the oxidative part of the pathway will utilize glucose 6-phosphate as a substrate. So the pentose phosphate pathway will use the glucose 6-phosphate pathway as substrate. Of course, you know the meaning of the substrate, right? The substrates and the products. The substrate will be in the start of the reaction and the product will be the last product or the biomolecules that we can have it at the end of the process. Okay, so the oxidative steps will utilize glucose 6-phosphate and will generate an ADPH. The reactions of the pentose phosphate pathway generally can be divided into oxidative non-reversible phase and non-oxidative reversible phase. Please focus on the reversibility of the phases. Okay, you know the reversible and non-reversible steps. What the meaning of this, right? So the oxidative arm or the oxidative phase is the non-reversible one, while the non-oxidative phase is the reversible part. So the oxidative step will utilize glucose 6-phosphate that undergoes dehydrogenation to give pentose, which is ribulose 5-phosphate, right? So the first phase will be the oxidative phase, where glucose 6-phosphate will undergo dehydrogenation. Dehydrogenation. The reactions is going to be dehydrogenation reactions. And it will give us pentose sugar, which is ribulose 5-phosphate. Okay. Non-oxidative reversible phase will start with ribulose 5-phosphate, of course, which is going to be converted back to glucose 6-phosphate by series of reactions. Okay, if we let's see the non-oxidative reactions. The non-oxidative reactions of pentose phosphate pathway are primarily designed to generate ribose 5-phosphate. It will convert the 5 carbon sugars into both fructose 6-phosphate and glyceraldehyde 3-phosphate, which also can be utilized by glycolysis. The main enzymes in the non-oxidative reactions, okay, are called transaldolase and transketolase. Okay, so transaldolase and transketolase are the primary enzymes involved in the non-oxidative steps of the pentose phosphate pathway. If we have a look to this diagram of the non-oxidative stage of pentose phosphate pathway, it can show you, okay, the reactions of the reactions of the pentose phosphate pathway, but which stage? The non-oxidative stage. Okay, which start with ribulose 5-phosphate. Okay, where it's gonna give us a first product, which is ribose 5-phosphate and xylulose 5-phosphate. Then by transketolase enzymes, both of them will give us glyceraldehyde 3-phosphate and acetylheptulose 7-phosphate. Then by another enzyme, which is, we can call it transaldolase enzyme, glyceraldehyde 3-phosphate plus acetylheptulose 7-phosphate can give us erythrose 4-phosphate and fructose 6-phosphate. The xylulose 5-phosphate, okay, with erythrose 4-phosphate by transketolase enzyme can give us fructose 6-phosphate and glyceraldehyde 3-phosphate. Okay, so what is the transketolase? The transketolase is one of the enzymes that has a role in non-oxidative reactions. Okay, it will transfer two carbon groups from ketose to aldose.